This time on Remaking Super Mario World in Godot, a lot more than I thought. From reverse engineering things on the SNES to building them in Godot. Join me as I put the literal finishing touches on the first level, learn how to use shaders, and finally build the Overworld map. Hi there! I'm Y, and to teach myself game development, I'm remaking Super Mario World in the Godot engine. And this time it feels like I've learned more than ever. Last time I left off with a pretty much complete level. And the plan for this video was build the overworld, make some shaders, and implement water physics. The water physics will actually have to wait until next time, because even without them I have a ton of progress and fun facts to share. But before it gets too interesting, let's start by doing some cleanup. Refactoring just means reorganizing your code, or your project structure. That can mean splitting up a huge block of code into parts, merging similar blocks of code into one, or just removing duplicate code. The goal is to have it do the same thing, but be easier to work with and cleaner in general. And right now I've got quite a few things that could be cleaner in general. Refactoring number 1, the player script. Mario is a complex little creature. To make his movements and animations work, there's a lot of code involved. And it's all in this one huge player script. It was already pretty lengthy when I made Mario's physics in part 1, but now that I've made power-ups too, yeah. And that's not even all he has in the original game. This could really do with some splitting up. A lot of this code has to do with physics, and another lot of it has to do with animation. So I'm gonna take those parts out of the player script and put them into child nodes instead. These are two nodes whose only job it is to have a script attached. With the process function, that code is gonna run automatically every frame, just like before. The only difference is I can't access variables from the player script directly anymore, so I have to prefix them with owner. But that's a small price to pay for a bit of organization, because now when I'm looking for physics or animation code, I only have to scroll about half as far. Refactoring number 2, state machines. I've talked about state machines a bit before. They're a way to structure logic by splitting it up into states and defining transitions between them. I've used state machines a lot when I made Mario ROM hacks, and now I'm finding more uses for them in Godot too. I'm implementing them as a bunch of nodes with scripts attached. The state machine node keeps track of the current state, and each state defines what to do in it and when to change to another state. I'm now using state machines for the spawning and despawning behavior of entities, and also for Mario himself. Not with separate states for movement, because that's still pretty hard to untangle, but rather gameplay states, like entering a pipe, getting a power-up, or dying, because those are all very distinct from each other. And that, along with moving away the physics and animation code, helps break down this huge script into more manageable pieces, which should come in handy when I add in more states like underwater or flying. Refactoring number 3, animation players. When I started this project, I didn't think I'd need to use animation player nodes, but it turns out they're really useful. They can do more than you might think, or well, more than I thought. Animation players let you change values along a timeline, and not just animation frames like the name would imply. You can change pretty much any property of any node. For Mario's graphics, I was using a simple animated sprite 2D node. Some of those frames need to be shifted by a pixel or two, and it's always bothered me that I had to change the offset through code based on the animation frame. But with an animation player, I can animate both the frame and the offset at the same time. And much more if I ever need to. Just make sure not to mess up the frame rate. Refactoring number 4, making a game scene. The player is a child node of the level, right? That makes intuitive sense, and that's how I've been doing it. But now that I have more than one level, there are two entirely separate players that I need to keep in sync, and that feels a little awkward. So here's something I learned. This remote tab isn't just decoration. When you run the game, it gives you a live view of all the scenes. This is the root of the scene tree, here are my auto loads, and here's the level scene with the player in it. And here's something else I learned from a handful of videos. Just because the player is technically inside the level, that doesn't mean it needs to be a child of the level. It should be its own thing in the tree. Mario can still interact with the level, but now he's independent from it, so I can keep him the same when the level changes. But I can't just put the two next to each other like that, because as far as I know there can only be one current scene. So instead, I'm making a new scene simply called Game that has them both as child nodes and that never changes through the entire game. Last time I made a level switcher script to remove the current scene from the tree and swap it out with another. Now I can just give that functionality to the game scene instead, make it swap out its level node while keeping the player node intact. And there we go. I still don't know if this is how you're supposed to do it, but I'm feeling a lot better about this. Now that was a whole lot of talking for nothing visibly changed. But hey, that's the idea of refactoring. And now let's make some progress. I have a confession to make. Last time I said the first level was complete, but I was actually still missing something pretty important. The goal point. I thought it would be really quick to make and not worth mentioning, but it turns out it can teach me a lot. In Super Mario World, touching the goal point sets off a long chain of events. It turns all enemies on screen into coins, makes Mario walk forward, gives you points and bonus stars, makes Mario show his victory pose, and does these fading and circle effects. That's gonna be a lot to coordinate. I'll just give you a whirlwind tour of it. First, let's make the goal tape entity. It actually has two hitboxes, one for when Mario passes the goal and one for when he cuts the tape, which is what gives you bonus stars. The tape moves up and down and you get bonus stars when Mario touches it, based on how high it was. From there, Mario starts doing the goal walk, which just means walking at a fixed speed and not reacting to button presses. Here's where the refactoring is already paying off. All I need to do is add a state to Mario's state machine, make it run physics but not input code, put Mario in that state when he touches the goal, and that's it. Mario also sends out a signal that the level listens to. That prompts it to turn all enemies into coins and to add this level end screen to the tree. The end screen is responsible for showing the number of bonus stars you got and also the scorecard that counts the points down and adds them to the status bar. The number of bonus stars is really going on a journey here. It's being calculated by the goal tape, passed on to Mario, who gives it to the level through a signal, then it gets passed on to the level end screen, and finally ends up in the scorecard script, which counts them up and shows the star formation sprite. It seems pretty convoluted, but it's actually the cleanest way I could think of, so yeah. During the score countdown, there's a drum roll being played. That's just a sound effect that loops. And the part that loops is just this one bit of it. So how do I loop sounds in Godot? And how do I make the loop start somewhere in the middle? There are two things that turn out. It turns out the import tab is also not just decoration, but gives you options for how to treat the files. And it turns out that different file types give you different options. I've been using WAV files for sound effects so far, but that won't let me specify loop offsets. So I'm gonna use an OGG file instead. Good to know. Now all these events, the scorecard, the countdown, Mario stopping and walking off again, are happening on a strict schedule. How do I control that in Godot? My first attempt was using lots and lots of timers. But looking at this timeline, this is actually another perfect job for an animation player. It doesn't just let you change properties, it also lets you call functions at specific points in time. So I'm gonna make separate functions for all those events, and then call them through the animation player. It's still a bit tricky to get the timing right, but at least now it's just a matter of dragging a point around. Fun fact, did you know that you get a 1-up at the goal point when the tens digit and the ones digit of the timer are equal to the tens digit of the bonus star counter? Seriously, try it! It's a real thing that exists in the original game. And yeah, I'm making sure my remake is accurate to that. All this gold stuff took more time than I care to admit, but it turned out pretty nice. I'm still missing the fade out effects, but I'll get to that later in this video. For now, let's go where Mario is heading off to, the Overworld Map. The Overworld Map, also known by either one of those two words, is basically the game's level select screen. It has a world map and level tiles with branching paths. It's a completely different part of the game with its own rules and controls. And that's a first for this project, something that's part of the same game but has nothing to do with what I've built so far. Luckily, the refactoring is paying off again. I have a global game scene now, so I can just add an overworld node to that and also give it a state machine to let it switch between the level state and the overworld state. In the overworld state, I'm gonna make the level and player nodes hidden and disabled. They're still there, but only the overworld is active. And in the level state, I'm hiding the overworld and showing the rest. I'm really not sure if this is the best way to go, but it's what I need, and it works. So now that I have this blank slate of an overworld, what do I fill it with? In Super Mario World, just like everything else on the SNES, the overworld is made of background layers and sprite tiles. Same as for levels, but they're used for different purposes. Layer 2 has a tile map of 8x8 tiles that form the scenery. Layer 1 has 16x16 tiles for level spots, decoration and path tiles, more on that later. Layer 3 is for the frame and the level name display, and everything else, including Mario, is drawn with sprite tiles. In Godot, I could just take an image of the whole map and display it as one sprite, but I might as well make it a tile map too. But for the frame, I am just gonna use an image. Somehow that doesn't feel as wrong. In Super Mario World, the level name is a part of the Layer 3 tile map. But in Godot, instead of making words tile by tile, I'm just gonna add a regular text label and use the monospace version of my Super Mario World font. Looks about the same. And if you're curious about the font, I made a video about it a while ago. And for the life counter, I can just reuse the number display scene I made for the status bar. For the level spots, I'm making a new scene because there's gonna be multiple instances of it. This scene has a simple sprite, an area 2D to detect if Mario is standing on it, and also a handful of export variables, so I can set the level name, the directions Mario can move in, and the name of the level scene that gets loaded when he enters. Mario himself isn't nearly as complex on the overworld. There's no need for a physics body with intricate movement. The overworld Mario is basically just a fancy cursor. I'm gonna make him a scene with an animated sprite and an area 2D. Now I can determine which level tile Mario is touching, and when you press a button, the game switches back to the level state and loads whatever level scene I specified. That's pretty cool. But Mario does have some movement. He can walk between levels. And this is the first real challenge of building the overworld. How do I make paths for Mario to walk on? In Super Mario World, levels are connected through path tiles. There are 16x16 tiles on the same layer as the level spots that are invisible but affect Mario's speed when he touches them. The code for that is pretty involved, and honestly I haven't looked at it in detail. I was wondering if I'd have to do it the same way in Godot and reference all that code. But luckily, this is much easier here. I want something to follow a certain path, so why not use a Path 2D node? In Godot, a path is something with a start point, an end point, and as many points as I want between them. If I add a Path Follow 2D node as a child, I can set its progress to somewhere between 0 and 100%, and that will set its position along the path. And if I add a Remote Transform 2D node and connect it to Mario, that will also set Mario's position. Now I just need to set Mario's walk speed and update the progress value every frame, and there we go. I probably shouldn't set the rotation though. Instead, I can figure out Mario's direction from how his position changed this frame and change his animation based on that direction. Yep, that's working pretty well. Now I'm gonna make some paths to connect all these levels and add the Path Follow and Remote Transform nodes through code, depending on which path Mario is walking on. When you press a direction on the D-pad, I'm checking if the level tile has a path assigned to it in that direction and then make Mario walk along it. That seems right. Until it doesn't. The problem is that paths have a specific direction, and right now Mario's always walking from the start to the end, even if that means teleporting to the other end. Here's my crude solution. I'm gonna check if Mario's position is the same as the end point of the path, and if so, I count the progress down from 100% to 0 instead. And now we can actually have it both ways. But there's got to be more to this map than just walking between 3 spots. When you beat a level, it should reveal a path to the next one. So let's try and do that. In Mario ROM hacking, what happens when you beat a level is called an event. That includes placing new terrain on the map tile by tile to make the path light up, revealing the level dot, and unlocking a new direction for Mario to walk in. Placing new terrain is a lot more involved than you might think, and it's all because the tiles are fading in, which takes some work on the SNES. Here's what Super Mario World does. It instantly replaces the old tile with the copy that's using a different color palette, then slowly fades those colors to black. At the same time, it places a sprite tile above it and fades that in from black. And finally, it enables the color addition feature of the SNES to mix the colors. One is getting darker at the same rate as the other is getting brighter, so adding them together gives the original color again, or on the pixels where they're different, a blend of the old and new colors. It's a really intricate dance involving background layers, sprite tiles, and half of the palette space. And all that for this pretty subtle fading effect that you might not even miss when it's gone. I'm getting a feeling this was someone's passion project. Luckily, in Godot, it's much easier to fade things in. All I need to do is set the self-modulate property. So here's how I'm implementing Overworld events. I'm making an event scene with a list of sprites, and when the event is activated, I slowly fade those sprites in one by one. And finally, when Mario beats a level, I send a signal from the level to the game scene, which tells it to switch to the Overworld state and to activate the level's event. And there we go. We now have a basic game loop. You can enter levels, finish them, and move on to the next. And speaking of moving on, while making the goal point in the Overworld, I've left out quite a few special effects that I said I would get to later. Now that later is now, let's finally look into shaders. A shader is a program that manipulates what's drawn to the screen. I assume they're called shaders because their first use was to add lights and shadows to a scene, but these days they're used for all kinds of visual effects. Before I made this video, I didn't know the first thing about shaders. Now I know maybe half a thing, just barely enough to recreate the effects of Super Mario World. In Godot, you can attach shaders to individual nodes. To make a shader, I'm told you give the node a new shader material, ignoring what other materials there are for now, and add a new shader from there. The programming language is a different one here. I didn't think I'd see curly braces and semicolons in Godot, but nothing too unfamiliar. There are several kinds of shaders. Ones that can move vertices, ones that can change the color of a pixel, and some more. What I need here is a canvas item shader and the fragment function. That function runs for every pixel on the screen, and it lets me change its color by setting the color variable. For example, when I apply a shader to Mario's sprite and set the color to red, every one of Mario's pixels becomes red. Or I can change just the blue component. Or I can make the color depend on the position of the pixel within the sprite, known as UV coordinates. With those very basics covered, let's try and put shaders to good use. Shader use case number 1, palette swaps. Shaders have a texture function that lets me get the pixel's original color. Now I can check if that matches a certain color, and if so, output a different one instead. You can also set parameters, called uniforms, kind of like export variables. Those can be images too, so that way I can give the shader a palette to work with. When the current color matches one in the first row, it replaces that with the color from a different row. Which row it should use is also controlled by a parameter. When I use the palette swap shader on Mario, I can give him his Fireflower outfit, or even make him green. So now I don't need two separate sprites for different power-up states anymore. I can just make the same sprite use a different palette row. I wrote the code myself, but based it on a palette swap shader I found on GitHub. If you're ever in need of a palette shader, you should check that one out. Shader use case number 2, palette animation. In Super Mario World, some things change color to create a blinking effect, like dragon coins or level dots on the overworld. I can actually use the exact same palette swap shader here, and just add a script that changes the palette row every couple of frames. I could also use the built-in time variable to animate the shader, but with the script it's easier to pause the animation. Shader use case number 3, the iris effect. Or whatever you call that circle that closes in on Mario. Everything outside the circle is blacked out, and everything inside is, well, visible. To draw a circle, I need a center and a radius, and those are gonna be shader parameters, because they need to be changed over time through a script. How do I figure out what's inside the circle and what's not? I get the position of the current pixel, calculate the distance to the center of the circle, and check if that's less or greater than the circle's radius. Actually, I'm checking the squared distance against the squared radius, because that avoids some calculation, which is always welcome in shaders. For the same reason, I'm also avoiding the if statement, and instead directly use the answer to the question, are we inside the circle, as the pixel's transparency value. Oh, and the fade to black? I actually just made that by animating the self-modulate property on the foreground and background. I don't know, it seemed easier than making a shader. Shader use case number 4, the mosaic effect. When Mario enters a pipe, or when a level or the overworld appears, the screen fades in or out with a pixelation effect. On the SNES, you do this by writing to the mosaic register, which controls the size of these cells and which layers the effect applies to. As usual, there's a fantastic video about it by Retro Game Mechanics Explained. In any modern image editor, the color of a cell depends on all the pixels in that cell blurred together. But on the SNES, it only depends on the top left pixel. That means only a handful of pixels are actually controlling the mosaic, so the effect looks kind of jagged. But it's less work for the console. And it's less work for me too. In the mosaic shader, I just calculate the number of cells from the cell size and then take each pixel's color not from the current UV coordinates, but from the top left pixel of the cell it's in. But here's the thing. Well, here's one of the things. A shader can only affect the pixels that its node is drawing itself, so I can't just attach the shader to the level node and have it affect everything in the level. I spent ages looking for a solution, and eventually learned about screen textures. When I declare a variable as a screen texture, I get access to all the pixels on the screen, so I can just make a color rect node and put the shader there. But here's the second thing. I don't actually want to apply it to everything on screen. Mario and the status bar should not be affected by the mosaic. I thought this was gonna be really tricky, but then I learned that the screen texture respects the order that things are drawn in. The screen texture isn't actually everything on screen, it's whatever is on screen when the shader runs. So I can just put the node above everything that should be affected and below everything that shouldn't. This whole shader thing took me way longer than necessary to figure out. But now they're there, they really help give the game a bit of authentic retro feel. Now we can go from loading the overworld, to entering a level, to going through pipes, to beating the level, to unlocking the next one. And it all feels pretty nice. This video turned out to be mostly about Godot features and me finding my way around them. For the next one, I want to shift the focus back to Mario and the details of his physics. The plan is to make water physics next, like I promised last time, and also things like carrying items. And maybe look into cape physics too, just so I can say I've got the worst part over with. This is still missing a lot of features from Super Mario World, but now for the first time, it's starting to feel like an actual game. Thank you so much for watching. If you enjoyed this video, you're a freaking nerd.